How's it? How are you?
Excellent. Are you ready?
Good. I'm ready. Let's get going. How's it, guys and girls, boys and girls, ladies and gentlemen? So I'm Niels Berglund. I'm so chuffed to be able to present today here at Future Data Driven, this awesome conference. So we're gonna, well, you have seen this before. We'll look at how we can do analysis of lots and lots of data in almost real time using Azure Data Explorer. And I don't know, I mean, good morning, good day, good afternoon, good evening to wherever you are. Now with these virtual conferences, it's hard to know what time of day it is where you guys are. Here in South Africa, it is 5:30, 5:40 in the afternoon, in the evening. And yeah, so let's get going. So first of all, when you're doing a presentation like this, the presentation 101 says you have to have a self-promotional slide, and that's obligatory. If you don't, the presentation police will come and give you a fine. So here is my slide anyway. So I'm a software architect lead at a company called Derivco. We are out of Durban, sunny Durban in South Africa. We are doing online gaming. We're kind of all over the world, but we're headquartered here in Durban. I'm also an Microsoft Data Platform MVP. Been that for five years now, which is cool. I've written Yeah, I've written a book actually. First look at SQL Server 2005 for developers, where, as the title says, we had a look at SQL Server 2005 for developers. It was so. I'm a database guy, right? I'm an old, both in years as well as in usage of SQL Server, and SQL 2005 was kind of very cool for me. It was probably one of the better releases of SQL Server that Microsoft has done. Anyway. I'm talking at events, Data Platform Summit that just was Future Data Driven right here now. I've been talking at the Tech Dev Week in UK, SQL Pass, etc. Now, the last few years, it has obviously been virtual and not face to face. I hope that we soon can start to do face to face conferences again. Anyway, I'm, as I said, a long-time user of SQL Server, and I'm working quite closely with Microsoft around data and data-related things. Right, so that's me. How's it, guys? So the agenda today, we'll start talking about data. Data in general, not necessarily in Azure Data Explorer, etc., but data in general. Then we'll go over and have a look at Data Explorer, what it is, the architecture of Azure Data Explorer, following up with how do we ingest data into Data Explorer. So basically, right, if we want to be able to analyze billions of rows, as the title of this talk is, we need to get data into Azure Data Explorer first, and that's what this ingestion part will do. And then we will finish off, we'll try to spend quite a lot of time looking at how we can query data, what Azure Data Explorer is good at, etc. So that's kind of the agenda. So let's get on to the data part here. So data, right? I bought a book by the lead counselor of Microsoft. His name is Brad Smith, and in that book, the book is called Tools and Weapons, The Promise and the Peril of the Digital Age. In that book, there were some quotes that kind of stuck to me that sounded cool and kind of says a lot about data. And we start with this one, that civilization has always run on data. I mean, Moses came down from, came down and he had his tablets with him, and it's not your iPad, but it was like stone tablets. On there was inscriptions, there were scriptures, it was data that was on those tablets. Everything today is based upon data. Whatever we do, when we are getting ads, when we are getting spam emails, it's all based upon data. So every facet of our life touches data, or data touches every facet of our life. And the thing here with data is that has become a renewable resource. It's not like fossil fuel that, if you believe the experts, will run out at some stage or another. Data will always be there. And the interesting thing here is with data is that even when the times are bad, trade slows down, data keeps on going. Data keeps on being created, new data. And I mean, in the last year and a half, 2 years has kind of shown that with this whole COVID crisis, right? The trade has slowed down. We have stopped flying. I have not gone to any conferences, what have you. But there is still data. Data has increased. And if you're talking about increasing data, the landscape of the data is that, well, we are generating more and more data, which kind of is clear from the previous slide. And we are saying that in 2016, worldwide, we had around 16 zettabytes worth of data, and a zettabyte is a billion terabytes. I think it is, yes. So it's lots and lots. However, we are saying in 9 years' time that up to 2025, this data will have tenfolded from 16 zettabyte up to 163 zettabytes. So we are hoarding data, hoarding. And the thing is that we need to be able, we as organizations, as businesses, as people, we need to be able to handle this data, because if we're not handling the data, our competitors will. So if we're looking at big data, if we're looking at modern business and how data is related to that, I have here a graph where we, on the x-axis, we're showing data complexity. With data complexity, I'm talking about velocity and variety. And on the y-axis, we have data volume. So that's kind of the 3 V's of big data: volume, velocity, variety. And if we're looking at how it started way back when, right, when we had our sales systems, payables, payroll, relational databases driven, that drives ERP, CRM systems, I mean, the volume on data went up to from megabytes to gigabytes, and maybe sometimes into terabytes. But then came Web 2.0, and the volumes of data started increasing a lot, and we started collecting logs. We did digital marketing, we did search marketing, we did advertising, we had mobile phones, things like that, and both the complexity increased and the volume increased. Then big data hit us, right? With click streams, with wikis, with blogs, with log files, with a lot of stuff. And the data has now gone from, down here in the left-hand corner, to be fairly structured data, to becoming quite unstructured and of all types and shapes and formats, right? And by having this down here in the ERP CRM world, we could have data pipelines that were targeted to our individual pieces of data. However, when now the complexity increases, right? The data, quite often we're finding ourselves that we, instead of having sort of proper, I'm a database guy after all, proper relational data, we are now getting data coming in free text format, just to be able to store, to handle the data, because we do not want to create different pipelines based upon all these various type of data. So instead, we are treating data, or we are storing data quite a lot in a free text format, such as JSON, etc. And also where once again by down here in the left hand corner, we were aggregating data, we updated data. In the new world, we are just appending data. We are not pre-aggregating, we are just adding data as it comes. Right. Something more here is that we are now looking at more and more at real-time decisions, that it is not enough that we run a batch job and then one day later or however long time period later we get a result. We want to do this in real time or as near real time as possible. We're having more decision makers. We're having more people that are creating the data as well as using the data, and we're having more users of the data. So think about the BI team in a company, 10, 15, 20 people that are handling the data, that is doing analysis of the data, and then they are handing out the result to execs, what have you, right? But now when we are looking at real-time decisions, we may want to give this data to the end user. So for example, in my world, online gaming, that leaderboards, for example, is a big thing. So now all of a sudden the users of this data, I mean, becomes thousands more than it was before. So before we had the execs 50, 100 people. Now, well, LinkedIn, who viewed my profile? Well, in my case, it's not very many, but when you click on who viewed my profile in LinkedIn, you are getting analysis in almost real time. And I mean, that's millions of users that potentially could click that who viewed my profile at the same time. So our systems need to be able to handle this. The parts now to handle all this data we're having three distinct parts and distinct technologies to do that, and we're looking at the cold part where we do not require, or the data is not that fresh, maybe hours, maybe days. We are keeping the data around for years. The data is raw. The way we are handling it is, I mean, my ETL, my ELT, my batch processing, as I mentioned before. And when I'm running a query, yeah, I mean, if it takes a couple of minutes, it's okay. It could take hours. A huge batch job, yeah, it could take hours. I mean, and that is maybe acceptable. And the data we have now is sort of stored in an in a distributed file system. Well, it could, yeah, let's say that it's stored in a distributed file system like Hadoop, and we are running MapReduce, maybe Spark against this data. Then we're having the warm path, where the freshness of the data, the requirement to have fresh data is much bigger. Right? We're having a minute's freshness. We're keeping the data around for months, and then the data may go into the cold path. The data is raw. We are using this data to do ad hoc queries. Your machine learning team may be looking at it to do hypotheses and create models, what have you on it, right? And the way the technology here is column store, we are doing clever indexing, etc. And then we're having the hot pot where we are running, where we want seconds freshness. We do not keep the data around for that long. We may do in-memory aggregation. We're having CEP, complex event processing queries, stream analytics queries, and we want the result split second. Sub-second would be awesome. Right, and here in-memory cube, stream analytics, KSQL DB, what have you. So this is all various ways that we are handling data, and for this now, Azure Data Explorer this tool that we're talking about today, that sits here. It sits in the warm path and reaches somewhat into the hot path. It is not meant, sorry, excuse me. We are using it for exploratory purposes. It can handle large volumes. It can do really quick queries over, as I said, billions of rows, right? So Azure Data Explorer. If we are to believe Microsoft's marketing here, Data Explorer is a fast, highly scalable data exploration service, log and telemetry data. So Microsoft created Azure Data Explorer to handle their App Insight product, where App Insight, where we are sending logs to the cloud, and from there, so it was initially meant for log, as I say here on the slide, for logs and telemetry data, but it has since then it has increased the type of data that it is handling. So it has grown into now to be able to handle a lot of the various streams that we are seeing, that we saw, especially in the big data part of the previous slide, like well, once again logs, but when we click, so click streams, etc., where we want to store the data and we want to be able to analyze it, and we want to be able to analyze it quick. And it's the way it's built, it is really good at handling data from a lot of diverse data sources. That can be relational data, that can be semi-structured data, or that can be unstructured data. Right. So Azure Data Explorer, the artist formerly known as Custo. So initially, before Azure Data Explorer was sort of in general availability, it had a beta name, or its code name was Custo. And we may wonder where that comes from. I don't know how true this is, but it's a cool story anyway, right? So because we're saying with Azure Data Explorer, we're saying, okay, let's explore the ocean of data. I mean, we have tons and tons of data, and we want to be able to explore that data. And the question then, when we're thinking about ocean and exploring the ocean, who did explore oceans? Well, that was Jacques Cousteau, a French explorer. You have probably heard about him. He was big in exploring oceans. So that's where the story, the myth, says that the name comes from. I do not know how true it is. Cool. So something a little bit more serious than Azure Data Explorer. So we saw 2-3 slides ago that ERM, CRP, the big data, the Web 2, how we had a lot of different types of data. And Azure Data Explorer allows us to work with all this different type of data. And we will see a little bit later in this session how we are looking at structured data as well as nested JSON, etc., and how we actually can do free text queries against the data as well. It is awesome for handling millions of events, i.e. high velocity data coming in, and handling it, querying it in low latency. And we have, once again, right, we in 3 slides ago, we saw how we have these very diverse types of data, and we want to be able to query all that data. And Azure Data Explorer gives very powerful query capabilities to us, and it also includes the ability to do fairly complex processing of the data, like time series analysis, machine learning, behavior analytics, etc., all built into the system. And the query language that allows all this is fairly simple. It is not SQL, but it's fairly similar to SQL, and it is quite easy to handle, and it is a very, very interesting and powerful tool set that Azure Data Explorer gives us. If we look at where Azure Data Explorer fits into the big data world, then we see here on the left-hand side how we have data, right, that is being ingested into a system. And what we in the big data world want to do with the system, we want to do with the data, sorry, we want to explore data. Then we want to, and the exploration of the data then leads us to data prep and training of the data, and eventually to create models and serve out these models. The data, we are storing them into a big data store such as Azure Data Lake storage or Blob Store or something like that. And the capabilities that Azure Data Explorer has firmly puts ADX here in this explore block, where the data comes in, we are ingesting it. We'll talk more about ingestion in a bit. We are ingesting it here into Data Explorer. We are running explorative queries against the data and can, based upon them, decide whether we should go further to prep and train, etc., etc., etc. So that's where ADX sits. So the architecture of ADX is that we start with a cluster, i.e. a machine, one or more machine, right? That cluster, in that cluster, we have one or more databases. So if you are a SQL Server person like me, see the cluster as your SQL instance, but in this case, you have multiple instances, and then in that SQL instance, you have one database or more databases, right? Then the databases, they contain that whole tables. So and in the tables you have the data, and the data is sharded out into what we in Azure Data Explorer call extents, and the extents is what makes the Data Explorer really, really powerful and performant. And extent in itself is, well, that is worth 1 or 2 sessions, but we won't go into any more details of that right now. And all this sits in a cloud. Right, so Azure Data Explorer, you do not run it on-prem. It's a managed service sitting in Azure. Right? And inside the database, we have the notion about functions, we have the notion of materialized views, and we have the functions of indexes. But these indexes, we as users, we as end users, we don't do anything with that. It's Azure Data Explorer applies the indices based upon fairly cool algorithms. So this is kind of what it looked like. We're having a cluster. The cluster sits on multiple virtual machines, right? Then we have databases in the cluster, etc. And I said, and we have storage connected up to this. Right. So let's have a look here, and let's go into my portal. Sorry. So here is my Azure portal. So the way we are now creating a Azure Data Explorer is we are creating a resource and we are choosing Azure Data Explorer. I will not go in and do that right now because it takes a little bit of time, and since I was late, well, let's not do that. We eventually, when we have created a cluster, we have gotten a cluster. So here we see, and I have a cluster that I call Niels B ADX test. It's an Azure Data Explorer cluster. And in that cluster, I now have databases. And so I can click here on databases, and I see here that we have, I have 4 databases, Niels DB1, Niels B, yada yada, future data driven test. Let's create a new database. The weird thing with Azure Data Explorer is that if you're used to SQL Server, you're using Azure Data Studio or SQL Server Management Studio to create databases, etc. In Azure Data Explorer, you either do it through the portal, like I'm doing here, or or CLI tools like PowerShell, etc., etc., etc. But let's do the lazy way: create a database, and we call that future data driven. You're setting the retention period. How long should the data be stored for? And you're also saying how long should the data be sitting in a hot cache. So this 365 here is the data is stored in Azure Blob Storage. The cache is the data is cached in local SSD drives, essentially stored in RAM. Right. I'll just take it as is. Future data driven, cool. We create that. Then when we have a database, we need to set some properties of the database. So let's click on it here, and let's say properties, and I have the ability to change properties, what resource groups, etc., etc. it is in. But anyway, so now we have a database called Future Data Driven, and we will use that in a bit. Cool. So, right. Now when we have an Azure Data Explorer cluster, we have 2 services in Azure Data Explorer. We have an engine service and we have a data management service, where the engine service is sort of the service that takes data from somewhere. We'll see that in a bit. Takes data from somewhere, stores it in ADX, either in cache or in Blob Store, and it also handles incoming queries through APIs, so that when I query something in ADX, or if there's an API query, what have you, the engine service handles that. The data management service is the conduit between data pipelines and the engine service. So when you are ingesting things into Azure Data Explorer, you are talking to the data management service that then talks to the engine service. So it looks something like this, that once again on the left hand side we have stuff that generates data. Then the data comes in here via various ways and means. We'll talk about that in a second. That is then being ingested into being pushed into the data management service. Data management service talk to the engine service. The engine service puts down into local SSD or down into underlying Azure Blob Store. Right. ingestion. So we have seen the cluster. I have now my cluster. I have a database. How do I now do what we just saw here on the previous slide? And that previous slide is somewhat simplified here, where we on the left-hand side we see ways we can ingest, and we can ingest through SDKs, and we have SDKs for .NET, for Python, for Go, for JavaScript, and for Java. So you can programmatically ingest into your Azure Data Explorer. We can set up pipelines, manage pipelines. That could be event hubs, IoT hubs, event grids, or blob store, table store. We have plugins where we can create we have plugins for Kafka. I'm a big Kafka fan, so I like the Kafka plugin. We can through that we can then ingest through Kafka, Apache Spark, Logstash, and Microsoft Flow. So we have plugins for all that, and I mean you can create your own plugin. Essentially, a plugin is an application that you have built from one of the SDKs up at top, and then we have some tools. We have something called one-click ingestion, and we have something called light ingest. We will see one-click ingestion in a second. So that then comes into the data management service that pushes it into the engine, and we are back to what we saw before, how the engine pushes it into local cache SSD or into Azure Blob Store. Right. So what we need to do here, let's write some code instead. So if we look at this slide, this is what you do when you're ingesting. Well, you need a table, surprise, surprise. You need a retention policy, and that retention policy can either be on the database level, as we saw before, or you can set it on a table level. So the database retention period can be, as we had, 365 days in an Azure Blob, and I think it was 7 days in cache. You can change that for individual tables. We need to be able to, since the data can be dynamic, the table needs to know what we will ingest into the table. And we do that by setting up ingestion mapping. And then finally, we are creating ingestion policies saying if this is batch ingestion or stream ingestion. And yeah, I'll come back to that. So we'll come back to this. We'll see this in real live. We can ingest using two ways. We can do batch ingestion, where we are optimizing for huge volumes in one go, or we can do stream ingestion, where we're optimizing for low latency, lower values than in batch ingestion. Do we have so far any questions? I don't see any questions here in the chat. That's cool. So, right, let's then go and have a look at ingestion. So Costadinos, why different DB? Different to what? Okay.
George, can you elaborate on your question, please? Go ahead.
Okay, I'll continue with well, why are there different databases? Well, I mean, if you may have different databases for different type of data, for example. So you in the database world, you are segregating data to an extent based upon databases. So that's kind of why you have different databases, if that makes sense. I mean, it's so in SQL you have different databases. In most database systems you have different databases, and Azure Data Explorer just follows that kind of paradigm. that makes sense? Right. Cool. So what we can do here, when we are, we'll talk more about this in a second, but when we are querying, when we are doing things with Azure Data Explorer, we're using a language called KQL, a Custo query language. It is, and as I said, it's somewhat close to SQL, but not SQL. So we'll have a look at it here in a little bit later. But anyway, so just have a look here at the cluster we have, where we can see the address, the name, etc., etc. I have a dev cluster with only one box on it. What I want to do is I want to add myself to this database, or I'm adding an MSA user, which is essentially my email address. Let's hope that this works. Sometimes it's a bit. Let's run that and see what happens. Cool. So I've now added myself here to this database, which then allows me to use a query tool called Custo Explorer. You can also query actually from here straight in from the web UI. So let's click on, so we are in query mode, and you can now go into various databases here and query them. So now we have, as we see, we have 5 databases: future data driven test, etc., as we saw before. And here we can now run queries if we so want. But I'm kind of like this tool called Custo Explorer. So there we are. Right. So so ingestion, right? I am. Let's refresh here. And so on the left-hand side, I have my connections. And you should see, so this is my cluster. And then here is now future data-driven, the database we just created. So what I want to do is I want to create a table called storm events in this database. No, in this database actually. And we run that. Cool. We have created the table, and down below here, we're sort of seeing now what it looks like. So name, storm events, ordered column, start time, etc., 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 etc. Right. Then I want to ingest into it here, and now I'm doing a batch ingestion based upon a CSV file that sits in Blob Store somewhere. So what I'm ingesting here is CSV data based upon storm events that has happened in US during a time period. And we run that. Cool. I think that worked. Not sure. And let's run that again. Let's see. Right. So we now have here a count of 59,000 records in this table, in this database. So where we would have in SQL, we would have done something like select count star from storm events. Here we are doing storm events, pipe, and whatever I'm doing. We'll talk more about that in a second. Cool. What we also want to do is can I ask the admin here, how much time do we have? Since I was late, are we running late, or are we finishing on time?
I think we can do 5 minutes because we have the other session coming up.
Okay.
Okay.
Cool. So let's then quickly let's do this. So I have in that other database that we saw in future data-driven test, I have a table called wagers. So I'm not going to code this up here. And the wagers contains, as the name says, wagers from online gaming. And that wagers table, yes and yes, it is, you download and install, and it is free. So the wagers table contains wagers information from online gaming, and this is hooked up to an event hub. So that when I ingest data into the event hub, I am also ingesting it into my table. So I should have ingested here already. And yes, I right now have 1,000 records there. So what we want to do is we want to do something like, where is my, come on. Here's my wager generator. So I have here a .NET Core application that kind of emulates gameplay and generates some data. And the data looks something like this that we have here. We have an event ID. We're having an event ID, user ID, product ID, module ID. It may not mean anything for you. It's just some data which comes in as a message to the event hub. So remember, we started here with 1,000 rows, and then if I run this, let's change this to 10,000. Right. So if we now run this station, we're doing stuff, and now we are starting to generate events. We can hopefully, come on, I would like to see that I have, let's see if we're getting some data into here. So let's do wagers count again. And now we have 1,460 rows here. So we can see how my streaming ingestion continuously now ingests data into this table. So that is streaming ingestion. Cool. So let's go back to the slides a second, and excuse me, so the way we are querying Azure Data Explorer is by using custom query language, KQL. It is, as I said, similar to SQL, slightly different. We are using the pipe symbol to pipe commands, and in equality we are using equal equals. We can do full text index searches. We can do time series analysis. We have built-in machine learning features, etc., etc. Right? So it's a very, very powerful language. Let's go back to my Custom Explorer and have a look here at. So let's do this resting code. I have here a demo, and Microsoft demo database called GitHub, which contains GitHub events. So when we are doing something against GitHub, an event is created, and this has been captured and inserted into this Azure Data Explorer database called GitHub. And if I look at this, if you look at the count, have here, I hope you can see this, we have 1.2 billion records in this database. Quite a lot of data, right? We can, so let's do some aggregations here. So we are running GitHub event summarize is the keyword when we are doing when we're doing aggregations initially. So when we run that, we'll see again, well, total events 1.2 billion. This is from 1st of January 2016 to 5th of February 2019. And this took, I mean, this took less than a second to do this aggregation over 1.2 billion rows, which is cool. We have the ability to do visualization, right? So we're saying here now on this table GitHub event, we are doing a sum of the sum of the events. We are putting it in 1 day buckets created by bin, created at 1 day, and we want a time chart out of this. And when we do that, let me make this a little, sorry, when we do that, we now have here built into this tool a time chart. We have different types of chart, time chart, pie chart, etc., etc., etc. Cool. Right. So I see here in the chat window that why do I have a structure of the table? Isn't the whole idea no structure? Can we switch between stream batches without the redo data ingestion? Absolutely. One table can take both batch ingestion as well as stream ingestion. But so let's have a look at the question here about why do I have a structure? Let's choose. Let's look at this. We're looking at the GitHub event, and we can see here I have an ID, I have a type, all structure. Then all of a sudden, actor and repo. These are JSON data, right? And it could be any type of data because when we're looking at the schema, we can see how the schema says that these three, they are dynamic. So to answer your question, you don't necessarily need to have a structure of your table, but it helps. And if you then have unstructured data, you are marking that as dynamic. So if we now look at this actor again, well, the actor column, and we're seeing here how we have in this actor, we're having display login, right? That now sits inside this JSON blob in this actor column, right? So let's do this. What I want to see is the login name. So we run this GitHub event. Project means show, and show 10 of these, and we can now see how we have parsed into the JSON and retrieved out the login name. The final thing I then want to show here is that, so now I have 1.2 billion rows in this table, and what I want to do, and I want to go into this JSON blob in the actor column, and I want to do a distinct count of the login name. So D count is distinct count, and I look at display, actor display login. So 1.2 billion rows and a column which is essentially, well, almost free text. We don't have the schema for it, right? And when I run this, I'm getting 16,420,597 distinct unique login names, and that query took, oops, that query took 3.6 seconds to run on one node cluster, which in my book is fairly quick. Cool, I know we are running out of time. Query samples, okay, so we're getting more and more data. We need to be able to analyze it. Real-time analysis is becoming the norm. The Azure Data Explorer is the big data analytics platform, and we are using custom query language for to query ADX. Questions. This is my my email where you can find me. So please drop me questions. What I'll do is I will clean up the code. I will and put that together with the slides and share it out so you can get it from somewhere. And once again, please do not forget to do feedback. And once again, thank you for the organizers of Future Data Driven. It's awesome.